All right, this is going to be a video on correlation and regression and the relationship between them. A thank you to Sage and Leon Guerrero for posting these materials. So let's talk correlations first. So when we have correlations, we have two measures that are either interval or ratio or one of each. This does not work with the categorical variable. And what we're going to do is we're going to look at the relationship between them, how they covary. And in this data set, it is a rather ample data set with a lot of different characteristics, including happiness, number of hours worked, your education, your degree, who you voted for, marital status. Now, right now you're seeing the labels for the categorical variables. If you go up here and click the 1 and A button, then it'll switch over to the dummy codes. And dummy codes are just a numeric representation for categories where the number is not actually a meaningful number, it's just a code representing that label. Now back to the labels. Let's look at the correlation between the highest year of school completed and the number of hours worked last week. So to correlate, we go to Analyze, Correlate, Bivariate. And you can't really quite see the variable names in the way this box is right now. And there are some variables which are similarly named. So for example, there's highest year of school completed for yourself, and then there's highest years of schools completed for your mother, your spouse, and your father. Now let's look at highest years of school completed for this one, and we also want the number of hours worked last week, which is hours 1. So when we put those two in together, we don't need to worry about clicking on anything. The defaults will give us the output we want. All right, we see that there is a very weak but positive covariation. This means that as the number of years of school completed increases, there is a very slight increase in the number of hours worked last week. Or conversely, you can see that the number of hours last week varies along with the highest years of school completed. With this particular relationship, you would consider the highest year of schools completed most likely a predictor of sorts, because usually people have their schooling and then they have their work. Obviously, things don't always go in that order. So that is a correlation. We're going to remember this number and come back to it later, but we're going to make a scatter plot. And this is when we have a visual display of all of the data points lined up on a graph on XY axes. So in this case, we're going to want to have the number of hours completed, the number of hours worked last week on the y-axis as the dependent variable. And we're going to say it depends on the highest level of education, highest year of school completed on the x-axis. And with scatter plots, we also can rely on the default settings. Click OK. And you see this massive array of dots. Now, my students tend to hate scatter plots, and I don't blame them, because it is an exhausting visual display of your data, because you are looking at every single data point. And normally the whole point of a visual is to reduce the amount of information in a statistical test to something that can be easily understood by looking at it. I digress though. Where they are helpful is you can look at the relationship between the two variables. If you double click on it on SPSS and go over to fit line at total, again, this is the situation where we can just be happy with the defaults. And we see that there is a very slight but subtle increase in the two. And we also see some numbers here that are important. There's an equation here, y equals 35.59 plus 0.42 times x. If you remember back to your linear algebra days, assuming you remember your algebra days, this is the linear formula for plotting points on a line. And it's saying that this equation gives us a line across the graph that allows for the least amount of separation from the line on average for every data point. So this is done by calculating the distance from each data point to the line and looking at what's called the residual or error. And that is the distance of the data point from the line. And the whole point is this line has the least possible amount of error, or the least amount of residual separation between the data point and the line. We also see up here we have r squared linear equals 0.007. Now that number doesn't just come from the error, it is the percentage of variance that's explained based on the percentage of the dependent variable, in this case, number of hours worked last week, that's explained by the independent variable, the highest year of school completed. So 0.007, if we remember the correlation between these variables, the Pearson's R was 0.084. We're going to calculate the square of 0.084. And there's the square equals, and we see that is 0.007, and that matches here. So the Pearson's R correlation squared is the R squared, indicating that 0.7% of the variation in the number of hours worked last week can be explained by the highest year of school completed. Now we are going to go on to the next step, which is to conduct a linear regression test. We're going to go to Analyze, and then Regression, Linear. Our dependent variable is the number of hours worked last week. I don't know why, but I have a difficult time there it is. Number of hours worked last week. And then our independent variable is the highest year of school completed, which is there. And our statistics defaults, those are all good. We can just leave that there. Click OK. And what we see here is the R squared is the same R squared we have up here, as we should. And we see that the unstandardized coefficient is 0.417. This rounds to 0.42, and 0.42, as you can see here, is in the linear regression formula. What that means is that for every 1 unit increase in x, there's a 0.42 increase in y. For every 1 year of school completed, there's an increase of 0.42 hours worked last week. Now the other number that is relevant here is this one here, 35.59, and we can find that it is within rounding over here for this constant. This is the y-intercept. Now we can see that this is significant. It's 0.012, and that is the information for this specific coefficient. The ANOVA here gives us information about the model. And because we only have one coefficient in this particular situation, if we square that t, which is 2.524 squared, we get 6.3705, which is fairly close. You know, there's going to be some rounding error because this is not going to continue as far in the display as what is shown in the output. But this goes back to how if you do an independent samples t-test and then you do that one-way ANOVA with those same variables, the F statistics from the one-way ANOVA will be the square of the t-test value. Now that is how to do linear regression when you have one predictor or one independent variable. Let's continue this with two independent variables, where now we're going to add in to our model the age of the respondents. We're going to go to Analyze, Regression, Linear. And age of respondent is right there. Click OK. Now, one of the first things we can notice is that our R squared is a little bit bigger. We've gone from it being able to explain 0.7% of the variance to explaining 1.2% of the variance. We can see that we have more information in our coefficients table because now we have two coefficients instead of one. With the unstandardized coefficient, what this means is that for every 1 unit increase in the age of the respondent, so going from age 33 to 34, there is a 0.077 hour decrease in the number of hours worked. So basically, as you get older, you work a little bit less every year. Now, it looks like there's quite a big difference in the size of the effect, but that if you only look at these unstandardized coefficients, the unstandardized beta. However, standardized coefficients have the coefficients on the same metric. So this is saying, so for highest year of school completed, there's about a 20-year range, whereas for age of respondent, if you look at this data set, it's a 60 or 70-year range. So there's a lot more years to have increases than there for age than there are years of school completed. By definition, you need to be at least your age for the number of years of school completed. You can't complete more years of school than you are old. So if we look at the standardized coefficients, this allows us to compare the relative strength of the relationship. So we can see the direction of the relationship, just like with correlations. A positive means if one goes up, the other one goes up. So as highest year of school increases, then what also increases is the number of hours worked last week. However, for age of respondent, we can see that as the age of the respondent increases, the number of hours worked last week decreases. These are both reliable, even though they are relatively small effects. So that is how to use linear regression, and I hope you found this helpful.